Welcome, my dear students in Prep 3. Let's continue lesson 1 in algebra, which is basic definitions and concepts on the circle. In this lesson, we will study some corollaries. The first one, the straight line passing through a center of the circle and the midpoint of any chord is perpendicular to this chord. So if we have a straight line, and this straight line passes through the center of the circle, which is M, and the midpoint of a chord, which is here AB. Okay, so this straight line bisects the chord. It means that CA equals the length of CB. In this case, this straight line will be perpendicular to the chord. And by the same way, corollary number 2, the straight line passing through a center of the circle and perpendicular to a chord, here the chord is AB, this straight line will bisect the chord. So the straight line here passes through M and perpendicular to AB. Then CA equals CB. Corollary number 3, the perpendicular bisector to any chord and the circle passes through the center of the circle. As we know, the perpendicular bisector, it means this line is perpendicular to a chord and in the same time bisects the chord. If a line bisects a chord and perpendicular to this chord, then this straight line will pass through the center M. And as we know, the axis of symmetry of any chord, it means the line which is bisects the chord and perpendicular on this chord. So it will pass through the center. And any straight line, as we said in the last session, any straight line drawn passes through the center of the circle is a line of symmetry of this circle. So the axis of symmetry of any chord of the circle passes through its center. So the axis of symmetry also axis of symmetry of the circle. Let's take some exercises. The first one here, we have a line segment BC, and this line segment is a diameter in the circle M, as you can see in the opposite figure. The line segment AB is a chord. MD perpendicular to AB. MD is a line segment drawn from the center to a chord, and this straight line is perpendicular to the chord AB. The intersection point between MD and AB is point D. Measure of angle C is 40 and AC equals 8. I want to find the measure of angle DMB and the length of MD. Okay, here as you can see, MD is perpendicular to a chord, and as we said, if it's perpendicular to a chord, it means D is the midpoint. So this line segment bisects the chord AB. D is the midpoint of AB. Okay, if you look at the triangle ABC, you will see that the line segment MD bisects two sides. Okay, the end of this line segment is the midpoint of two sides of the triangle. Then it will be parallel to the third side, which is AC, and its length will be half the length of AC. This is a theory from Prep 1. Okay, so DM parallel to AC and equal to half AC, and also DM is parallel to AC. Okay, DM or MD equals half AC, so it will be 4 centimeters. And of course, AC parallel to MD, then angle DMB will be 40 because angle DMB and angle ACB will be a corresponding angles because AC parallel to DM. Another exercise here. If AB is a chord of the circle M, AB is a chord of the circle M, C is the midpoint of AB, and measure of angle BMC, BMC equals 63 degrees. Find measure of angle MAB, MAB. Okay, as you can notice, the two triangles here are congruent. Why? Okay, MA equals to MB, and MA is a hypotenuse because MC bisects the chord AB, then it will be perpendicular to AB. So MAC and MBC are two right angles triangles. Okay, the hypotenuse here equals to the hypotenuse here because MA and MB are radii in the same circle, and CA equals to CB, and this is given. So here we have right angle triangle, hypotenuse, and side. So they are congruent. If the two triangles are congruent, then measure of angle MAB will be 180 minus 90 minus 63 because AMC, the measure of angle AMC will be 63 because they are congruent triangles. Okay, so measure of angle AMC will be 63. Then measure of angle, if you calculate the measure of angle MAB, it will be 180 minus 90 plus 63, so it will be 27 degrees. Let's move to another exercise. Here, for example, in this figure, AB and AC are two chords. Can you see AB and AC are two chords in the circle M into opposite side of M. A measure of angle BAC 56. BAC equals 56 degrees. If D and E are the midpoints of AB and AC respectively, find the measure of angle DME. Okay, MD is a line segment, passes through the center and bisect a chord, so measure of angle ADM is 90, perpendicular. By the same way, ME is a line segment, bisects a chord and passes through the center M, so also here we have 90 degrees. And this ADME is quadrilateral, so the summation of measure of angles 360. It means that the measure of angle DME, which we want, is 360 minus 56 plus 90 plus 90. Okay, so we can calculate the measure of angle DME. 360 minus 56, this is 56, plus 90 plus 90, it will be 124. Okay, that's all about our session today. I hope you have understand. Thank you very much for watching. Next session we will discuss the position of a point and a straight line with respect to a circle. Thank you very much for watching. See you next session and goodbye.